Hi everyone, this lesson is the first part of an integral by parts lesson. Now, in a lot of respects, integration by parts is a technique which is the equivalent integration process of the product rule for differentiation. So let's begin with defining two functions. So the function u, which is a function of x, and a different one v, which is some different function of x. Now these functions f of x and g of x could be anything. They could be trigonometric, algebraic, logarithmic, exponential, you name it, it could be them. So this little proof we're doing is quite general. Now let's begin by considering the derivative of the product u times v. So this, as we know, is u multiplied by derivative dv dx plus v multiplied by du dx. The opposite of a derivative is an integral. So if we integrate the left-hand side, we would get u multiplied by v. And the integral of these, well, it's a sum, so we could integrate them as two separate steps. So the integral of this first part with respect to x plus the integral of the second part with respect to x. Now it should be fairly obvious that those dx's will disappear, and so that gives us that we would have the integral of u dv equals u multiplied by v subtract the integral of v du. And that's usually the formula that you'll find written in textbooks under the heading integration by parts. Sometimes they're written in terms of slightly different ways with f-x's and g-x's and so forth, but that's the one that I prefer. I find that the easiest one to work with. That's enough for this instalment. We'll be back in a moment with some examples for how to use this thing.